Hello everyone, welcome to CS Lover. So in this today's lecture, we will understand about finite automata. So let's start. So what is finite automata? FA means finite automata. So what is finite automata? What do you mean by finite automata? Finite automata. So finite automata is broken down into two words, finite and automata. Finite can be said as finite number of states, finite number of states, and automata can be broken down into two words. Auto means automatic and mata means machine. So let's discuss it in the formal way. So what exactly is finite automata? So the formal definition says that fa is finite automata is 5 tuple. So what do we mean by tuple? For example, in coordinate geometry, it is coordinate geometry. Coordinates are two tuple, x and y. Okay, it is represented. The points are represented by x and y. So and this is two tuple. Okay. Similarly, fa is represented by 5 tuple. So fa, what are the 5 tuple? Q, sigma, delta, q naught, and f. Q, sigma, delta, q naught, f. So let's start with q. What is q? Q is non-empty finite set of states. Non-empty finite set of states. Finite set of states. Finite set of states. Sigma. What is sigma? Input alphabet. I have already discussed sigma in the previous lecture. Input alphabet. Input alphabet means the string, what the strings are made up of. This is input alphabet. Okay. Or input alphabets can be again described as non-empty finite set of symbols. Non-empty finite set of symbols. Finite set of symbols. Okay. So speaking of this symbol, let's discuss the symbol later. Okay, delta. Let's keep it a mystery. Okay, let's discuss this later. Now let's come to q naught. So what is q naught? Q naught is the initial state. You will soon realize what are these states that I am talking about. There I have mentioned final state of states. There I have mentioned initial state. So what these are, I will discuss soon. And q naught belongs to q. Okay, q naught belongs to a non-empty finite set of states. Okay, and then f is finite set of final states. Okay, finite set of final states. F i- F is a subset of proper subset of, yeah, S is a subset of Q. Okay, this means this is a subset of Q. This means F can be Q or F can take parts of Q. Okay, elements of Q. Q is non-empty finite set of states. Out of the states, F can be all the states. That is why this sign is there. This underline sign. It can take any one state, any two state. It can be also. That is what final state of state is. We will soon know it. Okay, let's talk about the FSCM explanation. What do I mean by it? Okay, one second. Okay, so finite FA consists of tape of infinite length divided into cells. So let's understand FA. What is exactly is finite automata? So finite automata FA consists of tape of infinite length. Okay, infinite length divided into cells. One cell store one symbol at a time. One cell can store one symbol at a time. One cell can store one symbol at a time. Let's take it. Tape. Let's take the tape. Okay, this is the tape, and these are cells of infinite length. Okay, cells, and the tape is infinite. Actually, the tape is infinite, not the cells. Cell is also infinite. You can store any string. Okay, so no, actually no. One symbol here is also mentioned one symbol. So each cell is capable of storing only one symbol. Okay, and the tape can of infinite length can be divided into cells. Okay, the tape is of infinite length and it is divided into cells. So let's so there is also a read buffer. Okay, read head, and there is a read head. Sorry, there is a read head. We have a read head. We have a read head, and one end of it is connected to tape. One end of it and one end of it. This is the read head. Okay, this is the read head. It reads symbols from it. This is the reader. Okay. And one end of it is connected to the tape, and the other end is connected with a buffer. It is connected with a buffer. With a buffer. Alright. What do I mean by buffer? Let's see. This is the buffer, and this buffer is called a FSCM. What is FSCM? Finite state control mechanism. FSCM is finite state control mechanism. Okay, finite state control mechanism. This is FSCM. FSCM, this FSCM store the current state of FA. Okay, this is the current state. Okay, this this store the current state. This is FSCM, and this is storing the current state. This is the state, and this is storing this FSCM. This triangular thing is the buffer, and this is connected to the read head, and the read head reads one symbol at a time. Okay, one cell from the cell, and this is connected. This read head is connected to buffer, and the buffer is also known as the finite state control mechanism, and the finite state control mechanism stores the current state of the FA, that is q naught. Okay, and the read head is unidirectional, and generally it moves from left to right. Okay, this is moving from left to right. This is unidirectional. This read head is moving from left to right. Okay, this is unidirectional, and this is the this is the finite state control mechanism explanation. Okay, let's move on to the next thing, that is the transition function, that is delta actually. Okay, representation of waves of FA. Let me first explain what is delta, and then I will cover the representational ways of FA. So what is delta? Remember, I kept it a mystery. Now it's time to unravel this mystery. So what is delta? Delta is transition function. Transition function. So, what do you mean by the transition function? Actually, one second. Yeah, let's consider this with an example. Let's explain it with an example. QA and one second. Let's copy this FSCM. Let's copy this tape. Copy. One second. That's done. So Q naught. What this means is actually this means Q naught on reading A. This read buffer reads A and stores and is connected to the FSCM. This read not read buffer. This read head reads A from the cell and is connected to the FSCM finite state control mechanism, which is this triangular thing, which is a buffer. Okay, and it stores the current state of the FA. And on reading A from the cell, uh, on reading and the Q naught, the current state changes to Q1. Okay, and it goes to Q1. Q1. Okay, this might be B. And let's see what this does. Let's see another example of explaining transition function. So Q1 comma B. Q1 on Q1 on reading B will move to Q2. Yeah. Okay, this is transition function. It is a function from which we can identify what will be the state after reading, after one state reads a cell. Okay, and the restrictions, yes, the restrictions that I have mentioned is it will read from left to right. This read head will move from unidirectional and it will move left to right. And this restriction later we will see. Later we will eliminate some restrictions and we will see that we will get more machines. Okay, we will get more machines. And let's so transition function. Okay, transition function can be divided into two categories. What do I mean by categories? Okay, transition function is divided according to the finite automata is divided, that is DFA and NFA. The major difference between DFA and NFA is based on the transition function. So let's discuss it now. What do I mean by DFA? What do I mean by DFA? Actually, okay, fine, no problem. DFA is deterministic finite automata. Okay, deterministic finite automata. And it is non-deterministic finite automata. Deterministic finite automata. So let's explain. Okay, so speaking about the transition function, one second. Okay, so the transition function are divided into DFA and NFA. One second. Divided into DFA and NFA. For DFA, it is this: Q cross sigma implies Q, and for NFA, Q cross sigma implies 2 to the power q, and this is the power set of q. Okay, I will explain it more. uh, and q equal to, let's consider q equal to q naught q1. Q is the sets. Okay, is the states, actually the states. Okay, and sigma is are the input alphabets. Across is nothing but the Cartesian product, okay, of set a and b. These both are states, a and b. Q equal to, again, q naught comma q1 sigma a comma b. Okay, so q cross sigma will just be the Cartesian product. Okay, a q naught comma a comma q naught comma b comma q naught q1 comma a comma q comma b. Q, what is remaining? Q naught q1 q1 comma b. Okay, this is nothing but the Cartesian product. Okay, and similarly, and this is a power set. Okay, q cross sigma gives the 2 to the power q. So this will be to the power q will be, and this RHS will be, I am looking into the RHS. You have found the q cross sigma. Okay, I will just consider the power set of q, that is sigma q naught q1 q naught q1. This is the power set of q. Okay, let's explain it with a proper diagram. Q cross q naught q1. q1 comma b. This points to, let's take this, let's just make it random, or it's for explanation of DFM. So this is a DFM. Okay, I mean, yeah, this represent q cross sigma q. And what will be q cross sigma 2 to the power q? You have identified 2 to the power q, that is the power set of q. Okay, so what it will be? Just take an example. Let's just copy this from here. One second. Let me first erase this, and let me place this. Okay, so what it will be? What are the power sets? Phi q naught, it will not be there. Then q naught, then actually it's q1 q naught q1. Okay, these are the power sets of q. So it will be a basic function thing. Just it will be just a relation. Okay, a pointer, a pointing, it will be a relation. Okay, relation with this and this, that's what we have created. It implies q cross sigma implies 2 to the power q, means it will be pointing to this direction. Okay, we have found a relation between two sets. Okay, that's what it is. So another quotation what we can write is another important point is every DFA is NFA and every NFA is not DFA. Okay, every DFA is NFA, every NFA is not DFA, every NFA is not DFA. This is a very important point. Okay, and by default, if there is something mentioned in the question, by default FA will mean finite automata will means NFA. Okay, let's move on the next topic. So let's discuss about the ways of representation of finite automata. So there are two ways with which we can represent finite automata. One is state transition diagram (STD), another is table method. Okay, we will soon discuss both the things. At first, but before, let's explain what is STD, state transition diagram. Let's discuss. Yeah. So STD are known as also known as diagraphs. Okay. Q naught, Q1 and Q2. So A, then what this means, Q naught on reading A goes to Q1, and Q1 on reading A goes to Q2, and Q2 on again on reading A goes to again Q naught. And if this stops on Q2, this the string will accept. Okay, it's basically, let's consider this. So here let's identify all the tuple here. Let's identify all the tuple here. Okay, for Q, what will be Q? Q will be Q naught, Q1, Q2. What will be sigma? Sigma is A, obviously in the input alphabet is A, and the transition function, what will be the transition function? So transition function is Q naught A, Q1. So what I was talking about? Yeah, sigma. So sigma equal to Q naught comma A equal to Q1, and then sigma, sorry, delta, sorry, what I was talking about, delta. Yeah, delta equal to delta Q naught comma A equal to Q1, and delta Q1 comma A equal to Q2, and this delta Q2 comma A is known as Q1, is Q0. Here see Q0 on reading A goes to Q1. Yes, this is correct. And Q1 on reading A goes to Q2. This is also correct. And Q2 on reading A goes to Q0. This is also correct. Yeah. And let's draw the two sets in Venn diagram. Two relations, actually relation. Yeah. Draw the relation Q cross sigma. So what it will be, Q naught comma A, Q1 comma A, Q2 comma A, right? That's it, na? Huh. Q naught, Q1 and Q2. Okay. So this will be this will be this, and this will be this. Yeah. And here the L will be, what will be the, before talking about the, let's describe Q naught. What will be Q naught? This will be Q naught. See, this is the initial state, and the final state is marked by double circle. Okay, Q naught is Q naught, and the final state is Q sigma delta Q naught F. Okay, Q naught, Q2, that's it. What will be L? L, as you can see, only a square, a a2 is accepted, a square accepted, a to the power 5 is accepted, a to the power 8 is accepted, a to the power 11 is accepted, dot dot dot. So a2, a3, a4, a5 is accepted, a6, a7, a8 is accepted. Okay, you can write it as like this: L equal to a 3n plus 2 n greater than equal to 0. See, it's a pattern actually. 3 0, put 0, it will be 2, put 1 in place of n, it will be 5. Okay, you can write by this pattern. Let's move on to the next subtopic, that is acceptance of string by DFA, definite finite automata. So how will you accept, what is the proper rules? So you have to start from initial state, okay, and then you move after reading entire input string, after reading you read every string, you read all the complete string, after reading entire input string, after reading entire input string. Okay, entire input string, what you do is you then the DFA must be at DFA must be at any one of the final state, at any one the final state. Okay, they, by this I can understand that the string is accepted by the DFA. If the DFA is any of and the DFA must be at any one of the final states. So you take the string, you accept it and take one symbol at a time, and after reading the entire input string, the DFA must be at one of the final state. In this example, see, yes, see, where was it? Yeah, one second, yeah, this this DFA, see, starts from Q naught, starts from the initial state, and reading the entire input string. Okay, and reading entire input string. What is the input string? For example, let's take it x square. A square is accepted. DFA must be at any one of the final state. Okay, and this is, by this we can know that the string is acceptable by the DFA. That is the proper definition, proper explanation you can say. So what do you mean by the language accepted by the DFA? Okay, so you have known that the string is accepted by the DFA. So if you want to know what how do you mean, what do you mean by the language accepted by the DFA? The language is nothing but the set of all strings possible over the input alphabet sigma. So talking about the language accepted by DFA, language accepted by DFA, accepted by DFA. Okay, accepted by DFA. Language is nothing but set of all strings. Language is nothing but set of all strings. So in the previous we just saw just for one string, and if every string in the language is accepted, then we will say that the set of all strings accepted by the DFA, strings accepted by the DFA. That is language accepted by the DFA. Okay. So let's come to NFA, non-deterministic finite automata. Sorry, non-deterministic finite automata. Let's explain at first. Explain it with state transition diagram. Okay. Okay. Control N. Yeah. Let's explain NFA with state transition diagram. NFA with a steady state transition diagram. So let's draw it. Q naught, Q2, 1 second, Q2, Okay, here let's identify all the tuple. Okay, at first let's identify all the tuple. Q is a, what is Q? What is the states? Finite state of states. Q naught, Q1, and Q2. What is sigma? Sigma is an input alphabet. What is this? This is the set of input alphabets. This is A. And what is transition function? See, on reading Q naught, this will be this is the transition function will be a set here. Will be a set. And on DFA it was not a set, it was just a single state, but here the transition function will be a set. Okay, the result will be a set. Q naught on reading A, there are two possibilities, that is Q naught and Q1. On reading A this comes to Q naught, or on reading A it goes to Q1. Okay, Q naught and comma Q1, Q1 comma A. Q2 comma A. Say Q1, K1 on reading A it goes to only Q2, that is why we wrote Q2, and on Q2 on reading A goes to, on accepting A goes to, on reading A goes to Q naught, that is why we will write Q naught, that is it, simple. Okay, and so Q naught, Q sigma delta Q naught F. So what is Q naught? Q naught is Q naught. What is F? Final state Q2. And this is Q naught Q sigma delta Q naught F. These are the 5 tuple. Okay. And what will be the language? You can say what is the language? A to the power n, or you can say anything, n plus 1, n, all this satisfies. See, if you 0, if you write 0, then it will be accepted. Will it be accepted? No, because n greater than equal to 2. So you have to start from 2. Okay, you have to start from 2. 1 second, yeah, we have to start from 2. L 3, 1 second, it's not actually 1 second, Q naught, oh sorry, I was wrong, actually this is not the thing, yeah. 1 second, delete. This is actually, this is the same language actually. So what this accepts, let's see, a a a a. Okay, so this is the same as the previous one. Okay, a is 8 3 to the power n plus 2. Okay, this is the language. Okay, so so let's come to the subtopic. 1 second. Acceptance of string by NFA. So how will you know that a string is accepted? So what is the explanation? So for NFA, there will be at least one path from initial state. After accessing it, NFA is at any one of the final state. Speaking of NFA, yeah, path, there will be at least one path from initial state. Okay, from initial state there will be one path. Okay, at least one path. You have seen there are multiple paths of reaching the final state. Okay, in NFA there are multiple paths. If there is at least one path from initial state to final state after accessing it, seeing it, NFA is at any one of final state, any one of final state, one of final state. Of final state. Okay. This is the acceptance of language by NFA. And what is language accepted by NFA? Language is nothing but the set of all strings. So, when the set of all strings will be accepted by NFA, then then therefore we mean that language is accepted by NFA. Okay. One second. This NFA. So, there are multiple ways of reaching this Q2. One way is A, 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 then A. See, actually this is not the right, actually that was the right, I am wrong. This is NFA actually, I am wrong actually, yeah, delete. Yeah. See what you can reach, see our reading A, and then uh, A, this is acceptable. The least one is A, and then you can accept anything after n. Okay, after n is 2. So this is the language. I was right actually at first. Okay, this is the language. If at least one path accepts it, then it will be accepted. The string will be accepted, and the language. What do you mean by the language? If every string is accepted, then the language is accepted by the NFA. Okay. See, A, then A. This is one path, and this is another path A. Okay, A. The one path you can see that for a single string there can be two paths. For example, you see this example. One second. For example, you see an example. See this string A. This string, this is one possible. Okay, one possible path, and another possible path is this A, double A, triple A, then A. This is another possible path. See, for this there are two and multiple two paths. There is two paths, and if at least one path from initial state goes to the final state, then we can consider that the string is accepted. Okay. Let's discuss. What is the table method. We have discussed the STD. Okay, state transition diagram. Let's discuss what is the table method. In table method is nothing but to represent the first the state in terms of table, in making a table. Okay, A, Q naught, Q1, Q1, Q2, Q naught. Okay. So what is this? Every cell exactly one entry. Okay. So this is C. Q naught on reading A will go to Q1. Q1 on reading A will go to Q2. Q2 on reading A will go to Q naught. This is the explanation. Okay. And this is the initial. This arrow denotes the initial, and this circle denotes the final state. Okay. This is the table method. Q naught for this FA, which I will be drawing in transition diagram. Set transition diagram. Okay. State transition diagram. I will be drawing as state transition diagram. So Q naught on reading A will go to Q1. Q1 on reading A will go to Q2. Q2 on reading A. Okay. On reading A again go to Q naught. This is the final state. This is final state, and this is the initial state. Okay. So this is the table method. So thank you for watching the second lecture.